Dave Russell, my colleague here, Dave Russell from Agronetics, and I are going to be talking to you for a few minutes about a project that was very much a collaborative project. Dave and I are the talking heads today, but there are a lot of people involved in this, and we want to acknowledge other colleagues, Brian Borman, Jeff Reeves, and James Tillepaugh from Agricultural Consulting Services and Agronetics. We also want to acknowledge a number of other organizations that were contributed or participated in the project. NRCS provided funding through a Conservation Innovation Grant. Green Kettering Sphere Program, Farmland Environmental provided resources. Myself from Pro-Dairy, again, as well as Agricultural Consulting Services and Agronetics. And we also couldn't do this without the farmer participants. We had two farms providing exposing themselves, if you will, on the dragline side of things. Hardy Farms in Lansing and Mulligan Farms in Avon. And we also had a couple of tanker farm systems here, lamb farms in western New York and R&R farms are Dykeman and Sons in eastern Vermont. What we're talking about today is a project where we were implementing or attempting to implement automatic shutoff technology on manure applications. Obviously, there are some regulatory and record-keeping opportunities here, and also there were some interesting challenges from a technical and equipment type of issue that we had to solve to address this application. This piece of data provided from the Agricultural Consulting Services database. About 4% of the CAFO land that they provide plans for is in a hydrologically critical area, some sort of setback near a stream type of situation. So when you think about it, it's a pretty significant chunk of the land base. Really requires no manure spreading or prevented manure spreading in these areas. Often these are high visibility types of situations, ditches along roads, residential wells, and those sorts of things. One of the challenges that I often see as I talk to farms or talk to farm staff or talk to planners or talk to DEC folks that are writing up farms for situations is communicating how do we get the understanding of the planner about where there's not supposed to be manure application. We communicate that by map, right? And then what happens to that information? Does the tractor operator or the truck operator have access to that map? Do they understand what those hash marks mean? Do they actually implement that setback? Okay. Very often, there seems to be a little bit of a communication breakdown there. Sometimes maybe the farm staff get it, it's been communicated, but you got custom operators who come into the mix and it isn't communicated to them. Okay, so there's some interesting challenges there that if we can find ways to help take out some of the human error piece or limit the opportunity for human error in implementing setback areas, that's what we're trying to accomplish. Okay. Another challenge is, so you've got a line drawn map, and how do you interpret that map when you're actually driving the tractor? How do I know? So that 100-foot line may be to scale on the map, but how do I really implement that when I'm out there driving machinery around? Okay, so we've got to look at some of those things. We all know that CAFO requires lots of setbacks, both from wells, water to the state, other surface waters, and P-index might drive additional setbacks. Sometimes we have fields where neighbors ask you to not spread, or as a good neighbor policy, you don't spread because it's been a problem. You may also want to have a prevented application on those sorts of things. We know that if there's a problem with DEC, being able to show that you follow the plan is an awfully good way to start to mitigate and sort of hopefully make DEC a little more comfortable about what's going on in a situation if there's a concern about a violation. haven't followed the plan and there's been some sort of water quality violation, the conversation takes on a whole extra level of intensity and concern on DEC's part. So again, all of these things are things that we're trying to manage better through implementing this type of project. So the objectives were to take off-the-shelf components and try to automatically control manure application, again, both on dragline systems and on either tractor or truck operated tank systems. We're going to pre-program the setbacks and those spread zones. We're going to set up the equipment to prevent manure application in those zones, and then set up the types of systems. We were pretty risk averse, or tried to be risk averse in how we were doing this, and rather than take real live no spread zones and conduct an experiment on them, really, we chose to set up artificial no spread zones just in case things didn't go as planned. And so what we did is we took a situation as though there were a well in the middle of the field, fairly extreme situation, but once in a while you see that, and we created a 100-foot arc, 100-foot circle around that artificial well concept. Oftentimes it's not unusual to see something maybe on the side of a field where you want to have a setback, something like this, and you might have a grass waterway or a little bit of a stub sticking out in the field like this. Again, so implementing these no spread zones, so it's artificial no spread zones. We flagged these areas in the field, so we literally measured. If we had a well in the middle of the field, we estimated where we wanted to put this well. We measured 100 foot out and flagged that area. And what happened then is in some cases, the tractor operator or somebody with a GPS unit would come out and literally snap in the points, that 100-foot setback in that case, or a 30-foot setback from a concentrated flow, whatever we had laid out. So it was flagged, and then someone with a GPS unit traced that out, as well as the field boundary to identify the no spread zone. What happened then is that information then went into the agronetics mapping group, and then they created a file with not only a target rate, but indicating a no spread in these areas. Okay. And then those maps got loaded into a field computer in the appropriate piece of equipment, and then we went out to the field and tested that. And right now I've reached kind of the edge of, at this point I start to get dangerous in terms of describing the technology, and that's where Dave comes in, and he can take you through the rest of the way with the important stuff.
I'll try to walk a line here kind of between too much detail to bore you and enough to give you the important information. If you think I've missed something, by all means, let me know. So in all cases in these systems, we've got three important items needed. We need a computer or display of some sort in the tractor cab that's going to tell you where you are, that's capable of displaying variable rate zones, and that can then control a piece of application equipment. In the case of the farms we worked with here, two of the farms chose John Deere applicators, and two of the farms chose to use Raven equipment. In both cases, the equipment that we're using is the same equipment that would be used to control fertilizer or spray applications. Thus, the off-the-shelf equipment was there. Talking to the manufacturers, they said, sure, we can use that. However, there is a reason that they don't sell that or promote it. There were some quirks we had to work through to get these systems to work the way we wanted them to for Manure. So two of the farms as stated were using tankers. Wayne Farms has a tanker on that they just purchased this year and mounted on a truck. They once again are using the Raven display screen with a controller. Dykeman Farms, who are going to be having a field day here in about 2 weeks, are going to be using the John Deere equipment and rate controller with a tractor tow tank. And you can go over that equipment a little bit more here in a little bit. One of the critical components to all of these systems is a flow meter. Most drag lines, when they're sold, have this piece of equipment already installed because it's really the only way to tell how much manure is being applied. But most tankers will not have it installed. It's kind of a pricey piece of equipment, $6,000 for a flow meter big enough to work in a manure situation. However, none of this is possible unless you know how much material is being applied. In the case of lamb farms, which are pictured here, the way we are controlling application is we're controlling the hydraulic flow to the application pump. So when we're applying, the flow is at full rate. Hydraulic fluid is going just as if nothing was in the system. When we get to the no spread zone, the solenoid here closes, the pump stops turning, and no manure should be applied. We did find one issue with that situation, and see if I can get this video to play and explain that as we go. So you can see the yellow flags there. That signifies the wellhead. Now the pump has stopped turning. You can see the flow is stopped, but it's cycling out. There's no valve there installed on this.
Those flags are a circle in the middle of this field, representing the no spread zone.
Problem in this case because it was just for a short period of time. We found when the tank was full, however, that flow could continue for quite a length of time. So if we were to do this again, and we still may install a valve there that the system could control and possibly shut that off.
Where was the smell?
Yeah, you're upwind. So in this case, you can see we're quite accurate in these pictures here. One thing, I thought there was a second.
Back up one more.
This one here might show another issue that we had that we would have to deal with. You can see the flags there. That shut off a little soon, and if you continue to watch the other side, it start up a little soon. Those are parameters that you can set in the system when it starts and when it actually stops in relation to the border as it's crossed. Kind of went out with this system and used it with the default settings, and when we get to the application map, you can see where we should have adjusted those. Yes.
What reasons are the system or just straight up?
In these cases, in these cases we were using WAS, which is going to be accurate within a foot, which is more than accurate enough for what we feel is necessary here. One of the drag line setups, the Hardy setup, was using RTK, but only because they had it already installed in their tractor for planing purposes, tillage purposes. When properly adjusted, these sorts of accuracies that you see here on and off within a foot of the flag are certainly possible with this type of system. Here's a demonstration of what happens when we shut off with a full tanker, though, and the siphoning that can happen. There is a valve on there already. You can see that tanker is set up to nurse, so you can divert that valve like they were going to nurse. All it would need is a hydraulic actuator, and the system's already set up to control that. So we don't feel that's a big issue. It's just an item we didn't foresee that we would need in this setup. This is the application map for that field. You can kind of see these areas here where we stretch things out into the no spread zone, and then there's some gaps in here where we wish to come on a little sooner or shut off later. You never know exactly which direction things are going, but those are all adjustments that can be made to the system. The map on the right hand side, the different colors show different rates being applied. So this is where we're talking if DEC ever has questions as to how much you put on and where. You can pull this information out and show them. You can actually go in quite fine detail. You can see some of these areas here that are in the no spread zone in real light colors. And right in there would be some cycling going on, but they're probably only rates in the few hundred gallon an acre range. So that was what we've already done with a tanker. Drag lines were a little bit more of a challenge for us. We knew they would be going in because we're going to have to deal with radio controls to a pump that's maybe a mile or more away. However, we thought with a spray-based system, it's already based on controlling a pump and a valve. We'll be able to idle the pump down and then close the valve on the applicator toolbar, just like you would in a spray application. It'd be just fine. One advantage to the drag line setup is we already have flow meters that we were able to use, but the addition that we had to add in those cases was the radio controls, which in one case were not already there. Kind of already gone over this. Valve at the tractor, which in this case would be right here, shuts off the actual flow. The system controls a radio signal that would send a signal to the pump, the lagoon, idles that pump down to where there's only low pressure. The issue we ran into, however, is the mile or whatever it is of hose that's laid out there. This system is not designed to account for as much lag as required to let the pressure bleed off from the time that pump is shut down at wherever the lagoon is to this actual valve here. That valve closes before the pump bleeds off. You find the weakest point in this hose pretty darn quick. Show you this video here. This is at Mulligan Farms. They're using a double ganged airway. That guy isn't smart enough to run the slideshow. They're using this airway to incorporate manure that's applied right in front of it. Kind of watch this. Right there, you can kind of tell that the flow is decreasing. That means the pump has received the signal, but the operator didn't choose to close that valve right away. He's waiting for the pressure to bleed off, and there he's closed the valve. That's the way we would recommend these systems be run for the time being. I can show you in a later slide what happened when we were at Hardee's and we thought the system could control that. It just wasn't very good. You can see the flag right there, which is the end border for this no spread zone. I'm going to watch right in this area. You'll see when it pops back on again. And there we go. Once again, we didn't take the time necessary to dial this in before this test, so it's closer, but there's another reason for that. Here's Hardee's, our first attempt at doing this. You can tell if that hose was in the wrong spot, we'd have been in a little bit of trouble, but working with them and Mulligan's, we came to the decision it just didn't make sense for us right now to try to take this and adapt it to where the system controls this. There's too many variables in place here. It depends how far away you are. It depends on the terrain, whether you're going uphill or down. It depends on the consistency of the manure. There's just too much here for this technology right now to be able to control. So what we ended up with at both places is we'll let the system control the pump. When that radio signal is sent, there's a auditory cue that the driver can use to say, okay, now I need to be watching my pressures. When the pressure drops enough, I'll go ahead and close the valve. One thing that does mean is that when we're building in these no spread zones, we have to have a border around the HCA area that's wide enough to accommodate that pressure bleed off. And that's something we'll just have to, we didn't do enough of these to be able to figure out how big that is, but that's probably going to be a 40 to 50 foot supply. The radio signals, especially at the Hardy location, were also another issue that we had to deal with. We're not reliable. Sometimes they seem to we seem to be getting signals that we don't know where they came from. I think the rest of these I've gone over. One couple of solutions we talked about in this problem is instead of controlling the actual speed of the pump, we could control a valve at the lagoon that just diverted the flow back into the lagoon. It doesn't really solve our problem because you still have however much line laying out there with fluid running through there at high speed that you're all of a sudden going to have to try to stop. We could deal with the radio issues by going to cellular technology, but that's more expensive. So I think our third option is the one, at least the farms we've dealt with and myself are most comfortable with right now. So this last option is not one to be ignored. You can save some equipment costs and still get a lot of the benefits of the system if we just say, all right, we're going to put the display in the tractor cab, let the operator watch it. He now knows where he is in the field. I'll show you a picture of what he can see, but he now knows where he is in the field, and he can then control everything manually. Save some of the cost in a rate controller and such. So this is a picture of the application map for the drag line setup in Mulligan's. We did 2 different fields. You can see where we dragged into these no spread zones further than we would have liked, waiting for the pressure to bleed off of these systems. Once again, those borders can be adjusted to account for that. And one of the benefits that a lot of people, or we didn't consider when we talked about this, is now you have a record of where those areas are. So if you need to go back with chemical fertilizer to make up and equalize the nutrient loads in the field, it's a whole lot easier to do that. So to sum up our experiences thus far, we're quite happy with the way the tanker operation worked at Lamb Farms. Obviously, we need to do something about this siphoning. That's a pretty easy fix. One item they brought up, so this is one of their trucks. They have another 3 trucks, and they actually use custom operators too. So a little bit of a tough sell to tell them, okay, you need to go out and buy 2 more of these right now. But one solution that most people are going to think of, so most of your fields only have edges or certain areas that are going to have these zones in them. If you keep the rest of your equipment in those other areas, you should be good. Drag line, we talked about some of the issues we had there, and we're pretty comfortable with where we sit. We don't think that this is the end of the story for those. I think things will continue to develop where we can do more. We're just not there yet. So we touched on it before, and I hope you can see by looking at those coverage maps that we now have a record. It's a little better than the Manure coffee stain sheet of paper that sits in most Manure spreaders right now for proving what went where if you ever need to. And I'm going to jump down here. So when too much manure puts on, in my experience, a lot of the problem is we're assuming, okay, there's a certain amount of volume in this tank, and we're going to put X number of loads on this field, and when we're all done, we know how much went on. Well, when you're all done and you find out you're 2,000 gallons over what you shot for, it's a little late. Now, with these systems, you know if you're putting too much on immediately, you can take action to rectify the problem. And in all cases, you now have a screen in there that's going to show you where you are in the field in relation to that screenshot. Guess I haven't got to it. Right there. So this is a screenshot of the actual what's the rating screen. This is the prescribed zero rate zone. You can see right up here, this is the rate that's supposed to be applied there. You can't see it off to the side, but there's actual, shows you the rate that is being applied. So as you're going across the field, you watch those two numbers, you can adjust what you are applying versus what the plan says should be there.
On the wall, right?
Yep, right there. So you can see he's in the no spread zone. This pink color indicates that or purple color, he's still applying 1,300 gallons per acre, even though he shouldn't be. I'm not sure if this is, I think this is off of ball against drag line setup. So this is a case of where he hasn't closed that valve yet, waiting for things to, the pressure to weed out. There's, over in this corner of the screen, you can't see it. There's another display of a pressure gauge that you can keep his eye on. Back up to we went over that.
So that flow meter takes away any of the issues of spreader calibration in
Exactly.
terms of the cable plan.
Yep. Yep. Makes that a lot easier. I mean, you don't have to worry about calibrating at all. The flow meters come from the factory pre-calibrated. So they're not the easy, you can see they're a pretty big chunk of steel to find a home for on some of these. That WAM application was a brand new tanker, and it took a while to find a spot big enough to, being a nurse setup too, certain parts had to be able to rotate, so there was some expense and time involved in getting that installed, but once it is there, it's a good situation. Carl, can you?
Yeah, there's just a point. This spring, there was a farm that applied some manure, and a few days later, neighbors started complaining about their water supply. Kind of familiar set of scenario there, right? This farm actually had, it wasn't associated with this particular project, but they had a unit, and they had the application rates from their maps. They had that saved. They printed it out. What was really helpful for that farm in the discussions with DEC, as I hinted at earlier, they were able to present those maps. It showed the rate. It showed that they matched or were under or very close to the planned allowed rate. And really that just sort of really settled the whole discussion down about, okay, well, what is it about this field that might have allowed this to happen versus what did you do to make this happen, kind of a thing. So it was really kind of a neat piece of psychology to see how that played itself out in the discussions. Actually did not, that case was resolved without a fine. They actually had some bacterial source tracking in water, and it looked like it was bovine sources, so it was hard to avoid the idea that some of that manure got into a well. But because they were following their plan, it was much more relaxed discussion.
So kind of along the same lines, another benefit here is the guys that are trying to plan fertilizer rates, you all know we make recommendations of a certain amount of manure, and they come back and say we put X number of loads on this field, so this whole field should have 6,000 gallons of manure per acre. Well, we know that probably this spot got 10,000 and this spot got 4,000. Now we can tell what went where. We now even have the ability to vary that rate if it makes sense. If we've got crop management zones set up to where we've identified areas that are going to yield more, we want more fertility in that area, and now have the ability to apply more or less in that area and track where we are and where those areas are. And obviously the inverse is true. We know areas where we didn't get enough manure, and so we need to go back with some commercial fertilizer. The whole point of this is it's kind of hard to come up with a justification for the expense side of this, because there's no, okay, you're going to get this much more money in your pocket because you have got this equipment. It takes a little more thinking, and this is kind of risk control. There's a lot of what you're doing here. The instant that Carl talked about, and the cases where you may not be able to apply manure and you want to track where those areas are so you aren't sacrificing yield. A lot of farms have already got a start on this now, or are considering it. And there's a big range there because there's a lot of different systems out there. There's a lot of different options. So everything below this can usually be added to the existing system. And also, if we wanted to manually control these things and just get this ability here in the cap to see this screen and know where you are, the rest of this isn't needed. So there's a lot of options, but the most important is to know where you are in the field in relation to where these no spread zones are. Now, if you want to get to the point where you're variable rate applying things, you're going to have to, should take that back. We are going to need this. And this is a tough sell to guys to say, I'm going to get a manure tanker out there that already cost me more than I wanted to pay, and I got to have another $6,000 item. But it can pay dividends. So what we need to do this on the tankers is the equipment we've just talked about, kind of the process we need to go through. Your pointer, the pointer in conjunction with the farm identifies the areas where they don't want to spread. Now the pointer is going to identify the areas, well, the CAPO law says you can't spread. You can also add in areas near houses, near neighbors, anybody you've made an agreement with, so everybody's on the same page. We're not going to spread there. We don't upset somebody who's land you're renting by sending the new guy down and he spreads someplace he shouldn't. We can then go out and either using the tractor with the equipment in it or using a handheld GPS device, we map those boundaries. A map can then be made, and once we've done the application, we've got that data in a secure format. Drag line's just a little bit different, and in this case we've said we're only going to partially automate this, so we're going to install the screen, and we've already got a flow meter. We're going to once again identify the areas we don't want to spread, but then the operator can just watch the screen and say, all right, I'm coming up on a no spread zone, I'm going to turn around, I'm not going to try to go through there. And we've already talked about these benefits. There's no guesswork as to how far 100 feet is. We've got the record of where we want.
Where's the record held, and then where is it printed out?
So there's internal memory in any of these screens. USB data stick, just like most of us have nowadays or are familiar with. Now you put it into the screens, you pull that record off, it keep it on the data stick and download it to your desktop computer, whatever works best for you. Once again, we want to thank all who are involved. And one more note, Dykeman Farms, they're going to be using a John Deere screen, the John Deere rate controller on a pull-behind pool tank. Right here is a valve. This is the only difference from lambs. Instead of controlling the speed of the application pump, we're going to be controlling that valve right there, which either sends the manure out the back to be discharged, or it sends it back into the tank for agitation. So they are still to have their field day in a couple weeks. If you are interested, there's some sheets in the back with directions, or I guess they're up here on the table. Shooting for the 13th, rain day of the 14th. That's all we have. If you got some questions, feel free to shoot them at us.
Good question. Does it look like this? Does it look like in Manure and stuff like this?
Well, in working with the manufacturers, it's one of these deals where, well, you show us the market and we'll put the time into it. Unfortunately, Midwest corn production and driving their tractors straight is a little more lucrative to them than spreading manure. Even Raven, who I was surprised because they should be into this type of thing, hasn't shown a whole lot of interest in taking it any further than where it is. It's kind of up to some independent guys to put this all together and make it work at this point.
Well, if it was farm demand, the manufacturer would have to follow suit.
Sure, but you've got to realize the Northeast dairy sector, and the dairy sector in the U.S. as a whole is a percent of.
Raven's going to put their money into controlling and hydration and spraying, not.
You've got. So, like I said, I talked to these guys on these things, and I said it would really be nice to have some help. And they're more than willing to help us with what they've already got and try to make it work. But they asked, "Will you go any further with this?" And so I talked to the regional rep, and he said, "Well, I got to submit all this paperwork and put it into the corporate guys, and they have to decide whether it's worth the R&D." And I just haven't gotten a whole lot of feedback.
Maybe it's just too small.
What's the DEC's perspective on seeing this type of information?
In terms of,
Well, are they thinking next permit term that, everybody's going to not be required to have this type of documentation?
I won't tell Jackie you suggested that.
I'm not
Did y'all hear what I heard?
Because that's the only way I see it really coming down is I got farms that really, unless you're the owner operator in a lot of cases, you're hiring some of the bottom of the barrel type employees that have a hard enough time reading the map, let alone put gadgetry like that on the front of them. And most farm managers I talk to aren't willing to spend that kind of dollar to have the bottom of the barrel operating that type of equipment.
The only thing is, Terry, if you've got a rate map for a field, it certainly shows at the bottom of the barrel over the
You would think.
Well, so those are the two sides of the story you have to be able to tell. Is that okay? Maybe you haven't got the brightest guy in the world, but 30 minutes with one of those screens, and you can show them the basics on what they need to do to follow it. It's a whole lot easier than trying to go through a whole set of maps and say, make sure you don't spread in this area that I've colored pink. That map usually gets tossed behind the seat, and away we go until he gets yelled at for being where he wasn't supposed to be, which is too late.
We used to play in video games, and these screens look an awful lot like some of those graphics. That's
especially if the gun comes up.
Yeah. Yeah, you got to have somebody You gotta have a picture of yourself popping out, shaking your finger at them, stay awake, right? But, so I think that, there's a bunch of farms that are gonna be doing, they're gonna have the screens, they're gonna have, maybe we're not gonna have 5 tankers on a farm with their own individual flow meters in them. The farms that have gone to the dragline systems where they got 1, maybe 2 units, that swallow in that $6,000 on a flow meter, and again, it's the only way you can tell really what you're putting on. Even without the automatic control, if they can have the picture on the screen and then the flow meter, I think you're going to see a portion of the farms.
And to get those maps with the rates.
Yeah.
I mean, that's going to a DEC inspection with those would be pretty darn nice.
Yeah, and it's I think people can be skeptical about it because it's a double-edged sword. It's like, well, what if I documented an over application? But I think, like Dave said, is you can see if you're over applying and you can make the adjustments before you end up documenting the whole field. And as long as your average is below that, you've got
Back
an
to your
opportunity.
employees again, I mean, so it's, I know you're not gonna pull out every application map and look at it if you're an over operator, but you put somebody in that tractor and you look at a few of them and see he's not paying any attention, well, you can do something before all of a sudden you find out, well, this guy spent all spring putting on whatever he wanted to.
And I realize many situations are not set up for a drag hose. There are some challenges there, but Jeff Mulligan said at a field day, I had one guy spread 9 million gallons of manure with a drag hose system. So now you can invest in one high-end person instead of doing the work of 5 maybe variable sorts of skill sets, and give them the technology and the capability so that they can manage some of the systems. So I think we're going to starting to apply some of a higher level of technology to our manure application as we've applied in other aspects of our farm businesses. I think it's a necessary evolution of where we're going. How that's all going to shake out, I can't say for sure. But some of this kind of stuff along this line is clearly going to be part of it.
So picture this, there's farms out there that are spending $5,000 to $10,000 for GPS rigs, so they don't have to steer and they can drive. Now there's benefits to that, but you can't put a very good solid dollar value on it. But it's convenient. And so this is convenient too, especially if you've already got one of those. You've got one of those systems. The add-on charges to be able to do this are not huge.
Does manufacturer of flow meter indicate if there's any change in accuracy with the different consistency of manure going through that unit?
These flow meters, the ones I'm familiar with, are made by Crone. They've done wastewater flow meters for a long time. They're magnetic induction units, so there's nothing actually in the flow. I'm taking their word for it, but they're kind of the standard in the industry.
I'm going to say let's pull the plug formally on this. If you've got individual questions you want to address, we can pick us up on the way out the door.
Three announcements before everybody leaves.
Okay.
Those of you that are leaving today, please fill out